Okay, section 5.3, when you finish this section, you'll be able to do number 7, 8, 9 in your homework. So this is normal distribution finding values. So now they're going to give us a probability and we're going to work backwards to find the value. So again, I'm going to show you two ways to do this. So in section 5.2, we were given a normally distributed random variable x, and we were asked to find a probability. In this section, we will be given a probability and we will be asked to find the value of the random variable x. So if you use the tables, the way you have to do this is that you, in section 5.2, we started with x, we converted to a z-score, and then we could use the table to find the probability. In this section, we'll start with the probability, we'll convert to a z-score, and then we can find our random variable x. So I'm going to show you again two ways to do this, one using the tables and one using Excel. Okay, so the way that we transform a z-score to an x-score, so basically we start with the z-score and we have to transform it backwards. So to transform from a z-score to a data value x in a given population, we use this formula. So I just wanted to start by saying where this formula comes from. So z equals x minus mu over sigma. So all we're doing here is solving for x. So z equals x minus mu over sigma. So first we would multiply by sigma on both sides, and we get x minus mu equals z times sigma, and then we add the mean to both sides. So that's how we get x equals mu plus z sigma. So we just took this formula, multiply by sigma on both sides, and then add mu. So it's just transforming this into x equals z times sigma plus mu, or x equals mu plus z sigma. Okay, so that's the first part that we need. And we can go ahead and put that into our Excel spreadsheet. So x equals z times, I guess they had it the other way, mu plus z times sigma. Okay, so that's the first thing we're going to need. Actually, that's the only thing we're going to need. So let's go ahead and look at the homework for these. And that's where I will show you guys how to do it both ways. Okay, so like I said, this is number 7 through 9. Okay, so use the standard normal table to find the z-score that corresponds to the cumulative area. So if I want to use the table, remember, these are my z-scores, and in the middle here is the probability. So what I would want to do is I'm going to go into, there we go. I'm going to go into the table and look for this value, 0.5 or 9559. So that's going to be in the positive part of the table because these are the ones that are above 0.5. So I'm going to look for 0.9559, and I'm looking for the probability here in the middle, 0.9599. I think this is the one that they asked me for. .9559. Not that one, 0.95. Ah, man. I'm gonna make sure I find the right one. 5, 5, 5, 5, 4, 5, 6, 4. Okay, so there is no 559, but the closest one is this one, 1.6 0.70. Oh, if it's halfway between, then it wants us to take the mean. So this is why I don't really like using the tables. Okay, so let's look. 559. If I add 0.5 to this and subtract 0.5 from this, I get the one in the middle. So it's going to be 0.705. 1.705. Let's check that one. Okay, so that's what it wanted. It wanted it to 3 decimal places. But let's look at how to do this in Excel. It's actually easier to do it in Excel. Okay, so they gave us a probability. The probability that Z is less than Z is 0.9559. Okay, so this is what they gave us, and they want us to find the corresponding Z-score. Okay, so to find Z, what we do is we go equals norm.inv. So I'm just going to use my down arrow to pick this one. And this is standard normal, so I want this one, norm.s.inv. This returns the inverse of the standard normal cumulative distribution. Okay, so I'm going to pick this one. So I hit tab. And then all I need to put in is my probability. So notice it wants a probability. So I put in this. Okay, and I got, and then the nice thing here, it wants it to 3 decimal places, 1.705. So it's a little easier to do it using this. All right, next question. Find the Z-score that has 72.9% of the distribution's area to its right. To its right. So remember, this gives me the area to the left. Okay, so if they give me the area to the right, okay, so they gave me the area to the right, and it says the area to the right, remember this, we need to first convert this from 72.9%. Okay, so I'm going to change that to 0.79. Okay, so we have to first convert it to a decimal because that's how Excel takes it. So I'm going to convert this to a decimal. That's what I want to put in. Okay, so this is my area to the right, but I always need the area to the left. So I'm going to go ahead and calculate that first. And the area to the left equals 1 minus this area. So the area to the left is 0.0271. And now my Z, now that I have the area to the left, I can use this formula. Okay, so Z equals norm.s.inv. And then I'm just going to put in my area to the left, like I always do. And it is negative, let's see, how many decimal places do they want? A Z-score to 2 decimal places. Negative 0.61. Okay, and then the pregnancy length in days for a population of new mothers can be approximated by a normal distribution with a mean of 270 days and a standard deviation of 8. What is the minimum pregnancy length that would be in the top 12% and the bottom 7%? So if I wanted to do this using the tables, the top 12%, remember that would be the area to the right is 0.12. So I would want to look up that the area to the left is 1 minus 0.12 or 0.88. So I would go into the middle of this table. I would find where the area is 0.88, which is halfway in between these two values. So that is 1.10, 2, 3, 4, 5, 6, 7, 1.175. Okay, so I would use 1.175, and then I would have to use this formula to convert this z-score back to an x value. So I would put in here for my z 1.175, and then I would use my mean and standard deviation and get back my x value. I'm going to show you instead, because I prefer to use Excel than use the table. So I'm going to show you how to do this using Excel, right? So they gave us a mean and a standard deviation. So let's start with that. This is number 9. Okay, so they gave us my mean. They gave us our sigma. Okay, so the mean is 270 and the standard deviation is 8. And then what is the minimum pregnancy length that would be in the top 12%? So we're going to start with this. And it wants the minimum. So basically, if we drew this, the top 12%, we were looking at the area to the left. So the number that's at the very end of that, that's why it's asking the minimum pregnancy length. Okay. So this one is top 12%. Top 12% means that we're looking at the area to left equals 0.12. Or sorry, area to the right is 0.12. So that means that I want to find first my area to the left. So remember, the top 12% means the area to the right is 0.12. So let's just go ahead and put that in there. Okay, so my area to the left is going to be 1 minus 0.12. Right, I put in these numbers. My mouse is sticking. And I put in this number. This one it calculated. So our x value that corresponds to that, right? Let's go ahead and put it over here. So the x value that corresponds to the 88th percentile, or the top 12%, is going to be equals norm. And now instead of using the standard normal, I'm just going to use norm.inv. And then I put in my probability, comma, my mean, comma, my standard deviation. So what I put in here is norm.inv. This is my probability. And then I put in my mean. And then I put in my sigma. Okay. So if you look at this, it's the probability, the mean, and the standard deviation. All right. And then it asks for the bottom 7%. And that means that the area to the left, that means the area to the left is 0.07. Okay, so the area to the left is 0.07. So now I can go right ahead and find my x. So I'm going to go equals norm dot inv. Oops. Go down this one, tab, and then my probability, comma, my mean, comma, my standard deviation. Okay, so the x and the top 12%, this should definitely be above the mean, and the bottom 7% should be below the mean. So that's kind of a check you can do to make sure that you didn't use the wrong probability. The top 12% should be above the mean, the bottom 7% should be below the mean. If you used this 0.12, you would get a number below the mean. All right, so the minimum pregnancy length that's in the top 12% is 279.4. Okay, and the maximum length, this is always going to give me the maximum below it at the bottom, and this one is 258.2. Okay, and now we can do section 5.4.